Hello everyone, I am Mart Swarna Latha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the center limit theorem. In the center limit theorem, again we are seeing two types of distribution. One is unequal distribution, the other one is equal distribution. So first we'll see what the statement of center limit theorem. The center limit theorem states that the probability distribution function is nothing but, it is also called as what? Cumulative probability distribution function. So the probability distribution function of sum of a large number of random variables is approaching what? The Gaussian distribution function. It means if you are taking a very large number of random variables, nothing but x1, x2 and so on, xn, these are n number of random variables where this n value is very large. Now if you add all these random variables, then the probability distribution function of sum of these large number of random variables is approaching the Gaussian distribution function. Therefore, the statement of the center limit theorem is nothing but the probability distribution function of a sum of large number of random variables will approach as a Gaussian distribution function. But we cannot guarantee the density function, but we can guarantee the distribution function. And in order to prove this center limit theorem, we are considering two types of distribution. One is unequal distribution and the second one is equal distribution. So first we'll go for unequal distribution. So for unequal distribution is nothing but what? We are taking how many random variables? N number of random variables. So x1, x2 and so on, xn. So like that you are taking n number of random variables. And each random variable unequal is nothing but what? Each random variable is having what? Different distribution functions. Thereby they have the different density function and thereby they are having the different means and variances. So what is unequal? It means each random variable is having the different distribution function and thereby they have the different probability density function. So if they have the different density function, it means they have the different means and they have the different variances. It means the mean of the random variable x1 is not equal to the mean of the random variable x2. And similarly, the variance of the random variable x1 is not equal to the variance of the random variable x2 and so on. So it means all the random variables are having the different distribution function or is also called as what? Unequal distribution function. Now, for example, how many random variables are taking? N random variables, x1, x2 and so on, xn. And each random variable is having the mean of xi bar. It means the random variable x1 consists of the mean x1 bar and the random variable x2 consists of the mean x2 bar and the random variable xn consists of the mean xn bar, and variance is sigma xi square. It means the random variable x1 is having the variance sigma x1 square, and the random variable x2 is having the variance sigma x2 square and so on. The random variable xn is having the variance sigma xn square. So it means they have the different distributions, different means and different variances. Now what is central limit theorem stating that? It is stating that when you add all these random variables and you are considering that the number of random variables are very large, and when you add all these random variables, let us represent the resultant random variable by yn. Now the distribution function of this random variable yn. How do you obtain yn? By adding a large number of random variables. Then the distribution function of this random variable yn is approaching what? The Gaussian distribution function if and only if the number of the random variables are very large. Now, in order to prove this central limit theorem for an equal distribution, we will not derive the thing, but we will define only the conditions for central limit theorem for case of the unequal distribution function. So, we will not derive the entire distribution function of this random variable yn is the Gaussian distribution function. Instead of that, for an equal distribution, we'll just state only the sufficient conditions to make this random variable yn is approaching the Gaussian distribution function. What are the two conditions? The first condition states that the variance of the random variable xi, nothing but sigma xi square, is always greater than b1. What is b1 here? It is a positive constant. There is a first condition. And what is second condition? The expectation of mod of xi minus xi bar whole cube is always less than b2. What is b2 here? A positive constant. And this represents what? Skew. The variance should be greater than some positive constant and the skew should be less than some positive constant b2. Therefore, these are the sufficient conditions to prove the central limit theorem in case of unequal distribution conditions. And when you go for equal distribution, in the similar manner, first what you are doing, we are taking n number of random variables x1, x2 and so on xn. After that, what you are doing, we are adding all these random variables so that we are getting a new random variable yn. Now, what the central limit theorem states that the distribution function of this large number of sum of the large number of random variables yn is approaching what? A Gaussian distribution function. Gaussian distribution function. And equal distribution. So, in the case of equal distribution, all the random variables, it means x1, x2 and so on xn, all these random variables are having equal, it means same distribution function, thereby they have the equal or same density function, and thereby all the random variables are having the same mean, same variance, etc. It means all these random variables are equally distributed, thereby the distributions are equal, their densities are equal, their means are equal and the variances are also equal. Now let us consider the mean of the random variable xi is equals to what? X bar. So for any value of I, what is I value here? From 1 to 3 and so on up to n. It means E of x1, nothing, the mean of the random variable x1 equals to x bar. And the mean of the random variable x2 is also x bar. The mean of the random variable xn is also x bar. It means all these random variables are having the same mean, nothing but equal mean. And what about the variance? Sigma x1 square equals to sigma x2 square equals to and so on sigma xn square. Nothing but all these random variables are having the same variance. In order to derive this central limit theorem for the case of the equal distribution, so what you are doing is, you are considering the random variable wn such that this random variable wn is having the zero mean and unit variance. It means, what does it mean? The mean of the random variable wn is equals to 0 and unit variance, nothing but the variance of this random variable is equals to what? 1. So, in order to derive this, what are we doing? We are considering a random variable such that the mean of this random variable is equals to 0 and the variance of this random variable is equals to 1. Therefore, what is wn is equals to yn minus yn bar by sigma yn. So, if you calculate the expectation of wn, you will get 0. If you calculate the variance of this wn, you are going to get as what? 1. Now, what is yn here? Y nothing but x1 plus x2 plus and so on xn. Now, how can I rewrite this equation as sigma I equals to 1 to n xi. Therefore, what is yn is equals to sigma I equals to 1 to n xi. And what is yn bar? Nothing but the mean of yn. So, what is yn bar? That is nothing but the mean of yn. Now, what is the mean of yn? Yn bar equals to mean of x1 plus mean of x2 plus and so on mean of xn. Nothing but x bar here, what is here? X1 bar plus x2 bar plus and so on xn bar. And nothing but, how can I write here? Sigma n equals to 1 to n xn bar. And what is xn bar value? That is a constant in the case of the equal distribution. And what about the variance here? the variance of the random variable yn, nothing but what? The variance of the random variable x1, the variance of the random variable x2 plus and so on, the variance of the random variable xn. And also you are assuming here all these random variables are statistical independent random variable. Therefore, what is the variance of the yn square? The random variable yn is equals to sigma x1 square plus sigma x2 square plus and so on, sigma xn square. Then how can we write out this equation as sigma n equals to 1 to n sigma xn square. Now you substitute the random variable yn and yn bar and sigma yn square in this equation 1. Then you can rewrite this random variable wn as what? Sigma, what is yn here? Sigma n equals to 1 to n xi. You can take I or n. So that depends. So sigma n equals to 1 to n xn minus what is yn bar here? Sigma n equals to 1 to n xn bar by sigma yn. What is sigma yn? You know the variance of the yn. Nothing but sigma yn square equals to sigma n equals to 1 to n sigma xn square. Now what is sigma yn? The standard deviation. Nothing but the square root of. Therefore, what is sigma yn equals to sigma n equals to 1 to n sigma xn square whole power 1 by 2. Nothing but the square root of the variance sigma yn square is nothing but sigma yn only. Now, so then how can you write this as? Here, what is the variance of this? The mean of the random variable is nothing but what? Expectation of xi. Nothing but, let us say, mu x. Nothing but is a constant or can take x bar also. So, mu x nothing but the mean of the random variable xi and x bar nothing but the mean of the random variable xi. So, you can represent the mean either by ux or as represented by x bar also. Then, how can I rewrite this equation as sigma n equals 1 to n xn minus what is this equation? Nothing but this mean is constant. Nothing but mu x or x bar. So, sigma n equals 1 to n xn minus x bar or mu x. So, you can write down like this also. Sigma n equals to 1 to n xn minus x bar also you can write down. By here, what is the variance? Sigma n equals 1 to n sigma xn square. So, over here, what is this variance? All these random variables are having equal variance. What does it mean? The variance of the random variable x1 is equal to the variance of the random variable x2 and so on. The variance of the random variable xn. Let us consider the variance of the random variable x1 is sigma x, nothing but sigma square or sigma x square, and the variance of the random variable x nothing but sigma x square, and so on. The variance of the random variable x is sigma x square only. It means all these random variables x1, x2 and so on xn are having the same variance. Therefore, you substitute here. Then how many times you have to add this one? N number of times. Then what is sigma n equals to 1 to n? Sigma xn square nothing but sigma x1 square plus sigma x2 square and so on sigma xn square. That equals to what? What is sigma x1 square? Sigma x square plus sigma x square plus and so on sigma. How many times you have to add for? N number of times. Therefore, that equals to what? N into sigma x square. Therefore, n into what? Sigma x square. And whole power here what? 1 by 2. That equals to what here? 1 by and square root of n into sigma x nothing but sigma x in square root of n into what here? Sigma n equals to 1 to n xn minus xn bar. In place of mu x you can represent by x bar also. So that is nothing but what here? So this is what the random variable wn. Now what you have to do? So what is wn equals to here? Sigma n equals to 1 to n and here yn minus xn minus x bar xn minus x bar by square root of n into what do you have here? Sigma x. So here sigma x. So x bar and mu bar are same only. Now, in order to say that the distribution function of this random variable wn, what is wn? Nothing but what? It is the sum of large number of random variables with zero mean and unit variance. Is approaching what? You have to show that Gaussian distribution function. Now, in order to prove that, what do you say? Here, you will prove that the characteristic function of this random variable wn is approaching the Gaussian characteristic function. Nothing but is a characteristic function, the Gaussian random variable with zero mean and variance is nothing but what? e power minus omega square by 2. So how do you prove the central limit theorem for equal distribution? You have to prove such that the characteristic function here, what is pi wn of omega, nothing but what? It is a characteristic function. So this characteristic function already we have seen in the previous lecture. So the characteristic function of the Gaussian random variable is equals to what? E power minus omega square by 2. And what is the mean of this one? The mean of the Gaussian random variable Wn is 0 and the variance is equals to what? 1. So for 0 mean and unit variance, the Gaussian characteristic function nothing but what? E power minus omega square by 2. So if you are able to prove the characteristic function of this random variable Wn, which is the sum of the large number of random variables with the 0 mean and unit variance as e power minus omega square by 2, then your central limit theorem is proved. So now we take this LHS part. So what is here? The characteristic function pi Wn of omega. So what is the characteristic function definition? Nothing but what? Expectation of e power j omega into Wn. So already we know that what is the characteristic function of random variable x? Nothing but what? Pi x of omega equals to what? Expectation of e power j omega x. So in place of x, the random variable, here the random variable is what? Wn. Therefore replace x by here Wn. Now what is Wn here? So from this what can I do? Wn nothing but sigma n equals 1 to n xn minus x bar by root of n into sigma x. So sigma n equals to 1 to n xn minus x bar by root of n into sigma x. So this is nothing but what? The characteristic function of the random variable w. And here the number n is constant here, the number of random variables, and moreover the standard deviation is also constant. So you can bring it outside. Then you can write this as what? 1 by square root of n into sigma x into expectation of sigma n equals to 1 to n xn minus x bar. So now you can rewrite this equation how? So 1 by root of sigma x into, so how many times, sorry, into what here? E power j omega x. This is what? E power j omega. So here expectation of e power j omega into Wn. What is Wn here? Wn nothing but sigma n equals to 1 to n xn minus x bar by root of n into sigma x. So that equals to, how many times you are adding? You are adding for what? N number of times. Then how can I rewrite this equation as what? Expectation of e power j omega by, you can rewrite this as what? J omega by root n into sigma x. So root n into sigma x into xn minus x bar. So how many times you are going to get this one? This you are going to get for n number of times. Therefore here write as what? N. So into what here? Pi Wn of w. So you are rewriting this equation e power j omega into sigma n equals 1 to n xn minus xn bar by root n into sigma x as what? Expectation of what? E power j omega by root n into sigma x. And how many times you are going to get this term? For n number of times. Because e power x plus y nothing but what? E power x into e power y. Like that, how many number of times you are going to get? You are going to get n number of times. Therefore, I am writing here whole power n. Now, so take logarithm on both sides. Then what can I write here? Logarithm of the characteristic function of the random variable w is equals to what? N into ln of expectation of e power j omega by root n sigma x into xn minus x bar. This is n. Now, what is the formula for e power x? Nothing but what? 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on up to infinity. Now, in place of x, what is the term here have? J omega by root n into sigma x into xn minus x bar. So, in place of x, you just compare here. Then what is the term here? J omega by root n j omega by root n into sigma x into xn minus x bar. Then how can I write out this equation? 2 as nothing but what? ln of pi Wn of omega is equals to what? Here n into ln of, so what is here? Expectation of ln of expectation of, so e power x, it is a 1 plus x, in place of x here j omega by root n sigma x into xn minus x bar. So this is x and x square by 2 factorial, nothing but what? J omega by root n sigma x into xn minus x bar whole square by 2 factorial plus remaining terms I am writing as what? Rn by n. What is Rn? Nothing but remaining number of n terms. So remaining terms I am writing as represented by Rn by n. Then that equals to what? N into ln of, what is the expectation of 1 is 1 only. And the expectation here j omega by root n into sigma x is constant. So bring it outside. So root n into sigma x. So expectation of xn minus x bar plus j omega by root n sigma x whole square. Then what can you obtain here? So you can obtain as what? Minus omega square by n into sigma x square. Just square this one. So j omega by root n sigma square. What? Minus omega square by n into sigma x square into what? Expectation. This is constant. This omega and sigma x is constant. And the statistical average always find with respect to the random variable. And therefore, can write as what? Expectation of xn minus x bar whole square plus expectation of Rn by n. Now, that equals to what? N into ln of 1. And here, what is the expectation of xn minus xn bar? You can write as what? So, you can write the expectation of xn minus x bar as what? U of xn minus u of x bar. And for any random variable, what is the mean? For equal distribution, it is constant and what? X bar. And expectation of any constant is the constant itself. Therefore, x bar equals to what? 0. Therefore, this term becomes what? 0. So, 0 minus omega square by, what do you have here? N into sigma x square. So, n into sigma x square. And here, expectation of xn minus xn bar. So, what do you have here? Expectation of xn minus xn bar square. Nothing but what? The variance only. So, sigma xn square. Nothing but sigma x square. And because variance for any random variable for equal distribution is constant, that equals to what? Sigma x square. Therefore, there is nothing but here sigma x square. That equals to what? N into ln of 1 minus. And one more term, what do you have here? Rn by n. So, expectation of Rn by n. So, equals to what? 1 minus omega square by n into sigma x square, and will be get cancelled. Then what do you get here? Omega square by n. So 1 minus omega square by n into here 2 factorial. Therefore here you get the term 2 also. 2 factorial nothing but 2 only. So you are getting here 2. And plus expectation of Rn by n. That equals, how can I write this as what? N into, how can I write the ln of 1 minus z? You can write ln of 1 minus z. You can represent by how? So ln of 1 minus z is nothing but what? Minus of z plus z square by 2 plus and so on up to infinity. Therefore here minus of 1 minus z. What is z here? Here z equals to what? Z equals to, you just compare this equation, this here. Then what is z equals to? Omega square by 2n minus expectation of Rn by n. Therefore here, what do you get here? Omega square by 2n minus of. So n into minus of, because it is minus of z plus. So minus of z. What is z here? Omega square by 2n minus expectation of Rn by n. So this is z plus z square by 2. nothing but omega square by 2n minus expectation of Rn by n whole square by 2 plus and so on up to infinity. So this is nothing but what? ln of characteristic function pi wn of w. If you multiply with n, then what get here? Minus omega square by 2. So minus of minus here plus e power expectation of Rn by n into n plus here n into omega square by 2n minus expectation of Rn by n whole square by 2 plus and so on up to infinity. So now if you apply n tends to infinity, then what can you obtain here? ln of pi wn of w is equals to what? Here there is no n term, therefore it is as it is only minus omega square by 2, and here if you apply n tends to infinity it becomes 0, therefore 0, and here omega square by 2n minus expectation Rn by n whole square. So here what you get here? Omega square by 4n square. If n will be get cancelled, the denominator will have the n. Therefore, if n tends to infinity, remaining all these terms becomes what? 0. So from this, what is the characteristic function the random w equals to? If you take the antilog, then you will get e power minus omega square by 2. Therefore, from this, what can you say that? The characteristic function of wn. What is wn? It is a random variable which can be obtained by a sum of large number of random variables with equal distribution is approaching what? The characteristic function of the Gaussian distribution function. Therefore, from this you can prove that the central limit theorem, which is stating that the probability distribution function of a large sum of a large number of random variables is approaching the Gaussian distribution function. In this, you have taken two cases. One is unequal distribution, the second is was equal distribution. For unequal distribution, you are just stated the two conditions, whereas for equal distribution, you have derived the central limit theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.